We're going to take a look at lesson 2.5, which is entitled Special Functions. We're going to split this up into a few different parts. The first part is going to have to do with what are called piecewise functions. So you see that here. And we'll talk about that right now. So it says a function whose value is defined by different expressions for various intervals of its domain. So it seems like a complicated definition, but it says it's a function, so we know it's a function, whose value, so a function gives us a value normally, or it does give us a value, is defined by different expressions. So the value is defined by different expressions. So in this example right here, y is our function. Its value is defined by different expressions. The first expression is x plus 3, the second expression is x squared, and the third expression is 1. And it's defined for various intervals of the domain. So x plus 3, y equals x plus 3 in the interval when x is less than or equal to, or less than negative 2. It's equal to x squared if x is between negative 2 and 2. And it is equal to just 1 if x is between 2 and 5. Now up here above this, I wanted to put this in here. I don't know if you've ever seen something like this. If you go to order something, I found this just today. This was actually for a compass for drawing circles. And it says if you buy 1 to 5, you pay $9.50 each. But if you buy more than that, 6 or more, you only pay $7.59 each. And so this is an example of a piecewise function because if your total cost, let's say C of x, and x is the number of compasses you buy, is going to equal, it's going to equal 9.5x, $9.50 times how many you buy, if x is between 1 and 5. And it's going to equal 6 or 7.59x if x is greater than or equal to 6. Now we could put in here that x is going to be natural number because we can't buy negatives or decimals of this thing, but it's still a piecewise function. So these are actually used in different circumstances. We're going to just look at domain and range here because it does talk about domain, the various intervals of the domain. So we've done stuff like this before, but let's go ahead and look at this. State the domain and range of each function. As I mentioned before, when we talked about this, to find the domain, I like to think of this as collapsing your function to the x-axis. So collapse this to the x-axis, whether it's up or down, and we would want to see, well, what's covered on the x-axis? And so the x-axis would be covered from here up to 4, including negative 1. So our domain is from negative 1 is less than or equal to x, which is less than 4, because we're up to 1, 2, 3, 4, but we don't have or equal to because it didn't include that. And then for the range, what we do is we collapse our graph, our function, to the y-axis. And we see that if we collapse this to the y-axis, the y-axis would be covered from negative 2, but not including negative 2, so just a less than sign, and we use a y, not an x, and it's less than or equal to 2 because it goes up to 2. Our next example here, the domain, will actually be in two parts here because we could condense this stuff or collapse this to the x-axis and it's in two different sections. So this first section is from -8 is less than or equal to x, which is less than or equal to -3. And we use the or equal to part because these are filled in. And then we have to put a comma or maybe semicolons better, and we put in our next part. So this is from 1 to 3, and we want to include 1 because it's got the closed-in circle, so we do less than or equal to x, which is just less than 3. We don't put the or equal to because that's an open circle. Then when we think about the range, we just really collapse to 3 and to 1. So the range is only two values here. It's 3 and 1. In fact, we normally put the smaller one first, so we'll go 1, 3. And the last one here, part C, the domain. Again, we can collapse to the x-axis. So it's going to be covered from -4 up to -2. So we have -4 is less than x, which is less than or equal to -2, because this was an open circle here and it was closed over here at -2. And then our other one collapses, and that's from 0 up to 3. So 0 is less than or equal to x, which is less than or equal to 3. And for the range, we're going to collapse to the y-axis. Well, over here, collapse to the y-axis, and then over here also. And so some of these, the numbers get hit twice, but it doesn't really matter. We just need to see what's covered. So it would be covered from 0, but not including 0 because it was an open circle, all the way up to 5. So our range is 0 is less than y, and it's just a less than, not less than or equal to because of the open circle, and y is less than or equal to 5. And so there's domain and range. Gets us thinking through those things again. So in example 2 here, we want to graph this piecewise function, and we'll state the domain and range. So what we're going to do here, I usually think of this in 3 separate parts. Well, in this one, I'm going to actually think of it as 3 separate functions. So just y equals, or f of x equals, -3. And really I'm just rewriting all of this. Our next part will be y equals x plus 1 if -2 is less than or equal to x, which is less than 1. And our third part we'll do in red, and that's going to be y equals -x plus 4. And that's if 1 is less than or equal to x, which is less than or equal to 4. And so all we do is we graph these functions, but we want to limit it to what our domain is. So I'm just going to start off by graphing y equals -3 and not thinking a lot more about that. So y equals -3, we know that's a horizontal line. So there's y equals -3. Graph the whole thing, but I don't want the whole thing. I only want this graph from when x is -5 up to -2. So 1, 2, 3, 4, 5. There's -5. So on my graph, I'm going to put a circle. And I'm also going to put a circle on my graph at -2. And so I just want this section in here. And I leave the left open. And sorry, the left gets closed in because it's got the less than or equal to. And the right side remains open. And this is one reason we use pencil, because now I want to erase the other parts that we don't need. So I only want from -5 to -2. Now I'm going to go to the green part. That's y equals x plus 1. Well, that is a line that has a y-intercept of 1 and a slope of 1. And so y-intercept of 1, slope of 1. So from there, we can go up 1 and right 1. We could put a few points in there to get what this is going to look like. and we can graph that line. And as you get better at this, you'll think ahead and you won't have to graph the whole thing and erase. You'll just realize what needs to be graphed. But we only want this from -2 up to 1, and that's our x value. So -2 is here, so we're going to put a circle at x is -2, not the y value, but the x value. And then we're going to put a circle at x is 1. Well, here's x is 1 for our green graph. And we want to close in the one on the left. Make sure we fill that in between, and then we can erase the rest of our graph. We didn't need that whole thing. Sometimes it's helpful to graph the entire line because you can see it a little better, but then you don't need it after that. Actually, you have to erase it after that because it's not part of the function. And the last part is y equals -x plus 4. Well, plus 4, that's our y-intercept. That's up here. And then we have a slope of -1. So down 1, right 1. And so it would hit these few points. And now I actually am going to think ahead a little bit here, and I know I only want this from 1 to 4. So I'm not going to graph the entire thing. I'm going to put a circle at 1, x equals 1, and it does get closed in. And I'm going to follow this line all the way till x equals 4. So x equals 4 is this line. So I'm going to put a circle there. And I'm going to connect that graph. So that's what you could do instead of drawing the whole line and then erasing later. You can think through the domain. This is also going to be a filled-in circle over here at x equals 4. And so there's the graph of that piecewise function. The next part here says write a piecewise function rule describing the graph. So in this graph down here, it looks like this is in 3 parts also. So we're going to have a function where this is in 3 parts. Let's kind of do the same thing. I'm going to sketch over this just so I can use the different colors. So that one's going to be blue. Red can go from here over to here, and this point right here is actually an interesting one. I'll go ahead and color this one red. It could have been colored in with the next color, which I'll use green, but we'll see that when we write our domains for the different intervals here. So let's call this f of x equals, and we're going to have 3 different parts. We're going to have our blue part. You don't really have to put these rectangles. I'm just doing this to separate into parts. We'll have our red section, and then we'll have the green section. And let's go ahead and look at these. I'm actually going to start with the red because that's the easiest. The red is a horizontal line. We know the horizontal line is just in y equals or f of x equals just some number. And we see that, even though I wrote through it, it's at -2. So y equals or f of x equals -2. Well, when is it equal to -2? We have to look at our x-axis. It's equal to -2 from -1 up to 2. So if -1 is less than or equal to x, which is less than or equal to 2. And I use less than or equal to for both of those because those circles were filled in. Now let's go up to our blue graph here. We obviously see this as a line. And the other thing we can see is what the domain is. So we don't have to go in any certain order. We know the domain is from -3 up to -1. So we can write that right away if we're going from -3 is less than or equal to x, which is just less than, because of the open circle here, -1. Well, what is this line? What we can do, to write a line, we need the slope and the y-intercept. So we see, just by continuing it, it would go through 2. So our y-intercept would be 2, and our slope, we notice, is just 1/1. So we have 1/1, which is 1. So x plus 2. we can think y equals x plus 2. And then our final part here, the graph of this green line, which is a little bit more difficult. In this case, we're pretty close to the y-axis, so we can actually just kind of work our way down because we need to find the y-intercept. We first can find our domain like we did before, our interval there. So we're going from 2 up to 4. And so we know this is from 2 up to 4. And what I'm doing here is I did not put the or equal to here because the green, we did not include this point with the green function. We include it with the red function. So you really shouldn't, you should not have an or equal to because it would then say we could use the red or we could use the green, and we don't want to do that. So we have our domain, and then we want to find the equation of this. We actually know the slope pretty easily. We're going up 2 and over 1, so this is going to be 2x. And it looks like we could find the y-intercept a few different ways, but this one it's going to be easy enough just to count it off. We could go down 1, 2 over 1, which brings us to -4. We're not quite the y-intercept. We could go down 2 more, -5, -6, and over 1, and we would realize our y-intercept is -6. And so there is the equation of that piecewise function.